Hey everyone, welcome back to lecture part 2 for camera basics. Where we left off, we talked a little bit about shutter speed, how shutter speed was measured in seconds or in fractions of seconds. And the larger the denominator on your fraction of a second, the faster the shutter speed. Remember, fast shutter speeds freeze our subject in motion, whereas slow shutter speeds, they capture movement or motion as your subject moves through the frame. So in this photograph, we looked at the photo on the left-hand side, and we know that that's a slow shutter speed because there's blur, right? Because there's motion blur, meaning as the subject is moving down the stairs, the subject being water, as the subject is moving down the stairs, the motion of that water is being recorded. So we have that motion blur. Whereas on the right-hand side, that was frozen with a fast shutter speed, right? It freezes the subject in motion. We can see individual droplets. We don't have that motion blur that we have on the left. So let's look at some more slow shutter speed. Slow shutter speed, by the way, is also called a long exposure. So slow shutter speed photos. Here's an example of one. This is a really popular type of photography called steel wool photography, where literally the subject will attach a piece of steel wool to the end of a rope and they'll light it on fire and then they'll swing it in circles. And as all the sparks fly off, because you have a long exposure, it records the path of the spark from the point of origin, right? From where the fire, the steel wool is burning, and it will capture the path of that spark as it flies through the air, and it leaves behind motion blur, the streaks of light, okay? So again, this is a slow shutter speed or a long exposure. Here are a couple more. You'll notice that long exposures, a very popular subject is light, because light, as it is recorded with a slow shutter speed, leaves behind like a trail, right? We saw the star trails, we saw the steel wool, and now we see tail lights, headlights in the photo on the left, and we see the motion of this ride as it spins around, okay? Now let's look at some different images. Let's look at some fast shutter speeds, what we call stopped action photographs. Photo on the left-hand side, we notice the subject is caught literally mid-air with perfect focus as he like does the trick on his skateboard. I don't know my kickflip. I don't know my skateboard tricks. My husband would be disappointed. And then in the middle, we have someone as he's jumping off of a diving board or maybe like a boat, and he's caught midair as he flips, okay? So that action is caught in a fraction of a second, probably like 1/4000th of a second. And then as we see on the far right-hand side, the splash of something into the water, okay? So all of these are caught with incredibly fast shutter speeds so that they freeze our subject in motion. And one last fast shutter speed photograph, right? We see individual droplets, no blur, no motion blur. That's how we know that it's a fast shutter speed, okay? So moving on, let's talk about the second leg of what we call the exposure triangle. The first leg was shutter speed. The second leg is aperture, okay? And then we'll talk about the third leg in just a bit. But the second leg of that exposure triangle is called aperture, okay? Now, shutter speed, as we said, was the shutter. It's how fast that shutter opens and closes, right, inside of the camera, inside of the lens. Aperture is the size of that opening, okay? So the shutter opens and closes, but the shutter opening can be really big or it can be really, really tiny. And again, that's determining how much light comes into the camera. Just like shutter speed, it lets light in really quickly, or it opens up for a long time and lets a lot of light in, right? With aperture, if we have a tiny, block this light, if we have like a tiny little aperture, right, that's not letting in a little bit of light. Whereas if we have a large aperture, that's going to let in a lot more light. All of this goes back to exposure. Remember, exposure is how much light we allow to enter into the camera, okay? Remember I had my camera yesterday for lecture part 1? I had a student that needed it this period, so I don't have it, but I'm gonna run over and grab it again. So excuse me while I pause this back. So let's go back to aperture, right? Aperture, like we said, is the size of the opening inside of our lens, okay? Grab my camera. Okay, the size of the opening inside of there, okay? So the shutter is the actual mechanism that opens and closes it. But the aperture is the size of that opening, okay? We can compare the aperture to the pupil of an eye, right? So your pupil lets light into your eye. And if you're in really dark situations, your pupil opens up super wide Whereas if it's really bright, your pupil gets really small. And your aperture does the same thing, okay? The aperture on the camera. In really dark situations, you want to open that aperture wide up. And in really bright situations, you want to close that aperture so it doesn't make your photo overexposed, right? And we measure aperture in f-stops, okay? What's an f-stop? I'll tell you in just a minute. But whereas with shutter speed, we measure it in seconds or fractions of seconds. With an aperture, we measure it in f-stops, okay? And changing your aperture affects your photo's depth of field. Shutter speed affected if our photos are sharp or blurry. And shutter speed, did I say that correctly? Shutter speed affects whether our subjects are blurry or sharp. And aperture affects our photo's depth of field. I'm going to talk about all of that in detail. So if you're feeling a little confused, don't worry. Okay, so let's look at a couple of aperture openings. So you'll notice that at the very top, that aperture is wide open, okay? And we call that hi, let me pause it. I had someone just walk in. For all the pauses the last couple days. Okay, so you'll notice at the very top image, that aperture is wide open. We call that a low f-stop. I know that's kind of counterintuitive. Aperture is hard to understand in the sense that it's opposite of what you'd think it is, okay? So a low f-stop actually indicates a large aperture, okay? A low f-stop indicates a large aperture. So for example, like an f1.3 would be a wide, super, super wide open aperture, whereas an f like 22 would be a teeny, teeny, tiny aperture. So the lower the number, the larger the aperture. The lower the f-stop, the larger the aperture. If you're taking notes right now, I want you to write that in your notes, all right? That's my little cheat sheet that I always give. The lower the f-stop, the larger the aperture. That means the opposite is true, right? The higher the f-stop, the smaller the aperture, okay? So if you can remember that, you're golden for aperture. And it does take a while to remember. A lot of people struggle with aperture because it's counterintuitive. It's opposite of what you think it is. But if you can remember, the lower the f-stop, the larger the aperture. And the higher the f-stop, the smaller the aperture, you'll be golden. Here's another image showing what we were just talking about, right? That f1.8, notice the aperture is gigantic, whereas all the way down to f22, the aperture is so small that you can barely see that there's an opening there. So as our f-stop gets higher, right, the aperture opening gets smaller. So as we said, aperture affects our photo's depth of field. Depth of field is the amount of a photograph that's in focus, okay? So for example, on our very top image, you'll notice that the foreground, that flower is in perfect focus and everything behind it is super blurry. Our eyes cannot travel very far back into that photograph. So because of that, we call that a shallow depth of field, right? Whereas if you go down to f22, you'll notice that the foreground and more of the middle ground and the background are in focus. We call that a deeper depth of field. Our eyes can travel from the foreground to the middle ground to the background and everything's in focus. Whereas with that blurry background, all we can see is what's in the foreground. So we call that a shallow depth of field. So cheat sheet time, ready? If your background is blurry, it's a shallow depth of field. If everything is in focus, foreground, middle ground, and background, then that means that it is a deep depth of field. So blurry background is shallow depth of field. Everything in focus is a deep depth of field. And you achieve those two. To get that shallow depth of field, you need a large aperture, which means a low f-stop. Whereas a deep depth of field, right, is everything's in focus. You have a high f-stop, which means you have a small aperture. I promise the more you practice with this, the less confusing it's going to get, okay? Hopefully you put that on your cheat sheet. If you didn't, rewind it, or I'll just say it again because I like to repeat myself. So shallow background equals low f-stop equals large aperture, okay? That's a blurry background, shallow depth of field. Everything in focus is a deep depth of field, so that is equal to a high f-stop, which means that is a deep depth of field, okay? Deep depth of field, high f-stop, small aperture. Okay, again, the more you practice with that, the easier it'll get. So we can see here with an f2.8, that is a large aperture. Sorry, I'm trying to move this a bit so you can see better. Okay, so you'll notice that with an f2.8, that's a low f-stop. That means it's a large aperture and our background is blurry. We have a shallow depth of field. Whereas on the right-hand side, high f-stop means that it's a small aperture, and so everything's in focus: foreground, middle ground, background. There are also applications for this. Where do you think a shallow depth of field would be better? Like what type of photograph? Okay. And the answer is shallow depths of field, which means, again, low f-stop, large aperture, shallow depth of field are often used in portraits because it blurs out the background and then your focus, your focal point is exactly where it should be, which is on the subject. Okay. So again, we see this portrait here. We have a shallow depth of field. Everything in the background is blurry, which means that I used a low f-stop, which means my aperture was large. I know I'm repeating myself over and over again, but I promise the more you hear this, the more it'll sink in. So shallow depth of field, blurry background, low f-stop. So all of our attention is on the subject. So what do you think we would use a low f-stop or a small aperture for? We use those to get that deep depth of field. We use those in landscapes so that we can see the foreground, the middle ground, and the background of our subject, right? We don't want anything blurred out in a landscape. We want to see everything. So because we want to see everything, we need to have a deep depth of field. We need to use a low f-stop. We need to use a small aperture. All right, moving on to our last, right? We had shutter speed, we had aperture, and now if I had another arm, it would go down here for the bottom part of our triangle, and that is ISO. Simply stated, ISO is your camera's sensitivity to light. And people often get confused by ISO, but I personally think it's the easiest one. All you need to remember for ISO, honestly, people might argue with me on that, but in my opinion, all you need to know for ISO, if it's super bright and sunny, you want a low ISO. If it's really dark, you want a high ISO. It just makes your camera more, the higher that number, the higher your ISO, the more sensitive your camera is to light. So it's like, oh, it's really dark in here. I need to make my camera more sensitive to light. So I'm going to turn my ISO way up. Okay. So for example, if it's really sunny outside, I'm going to keep my ISO at like 100 or 200. If it's nighttime and I'm trying to take photos without a flash, I'm going to bump my ISO up to 1600. Okay. So here's the cheat sheet time. Ready? Here's the cheat sheet time. If it's bright and sunny, use a low ISO. If it's dark, use a high ISO. And then obviously there's like a whole range in between. If it's like not super bright but not super dark, you're going to want to use an ISO right in the middle, like 800. Okay. So what does ISO do? ISO, because we know shutter speed affects if things are blurry or sharp, right? Aperture affects our depth of field, meaning is the foreground, middle ground, and background in focus, or does it blur out? ISO affects the grain of our photograph. So notice here with an ISO of 100, our photo is more sharp, but as we go up this range, the higher our ISO gets, the more grainy our photo gets, okay? So the rule of thumb again on that is low ISO, it's going to be more sharp and clear, and a high ISO, our photos are going to be more grainy. Some people love high ISO photos. They like their photos to look grainy, to look kind of old-fashioned, right? When we say grainy, like it almost looks, my more modern students like to say like what, like pixelated? And pixelated is not quite the right word, but you're on the right track, okay? But the right word is grainy. You can actually see the individual grains of the photograph. And that goes back to film, actually. Okay, so I already gave my rule of thumb. The more light you have, the lower your ISO. The less light you have, the higher your ISO. Okay, so again, this is all of this kind of summarized in what we call our exposure triangle. ISO is our light sensitivity, and it affects the grain in our photographs. Shutter speed affects motion blur versus sharp, and then aperture affects our depth of field, sharp, blurry, or deep, shallow or deep. I'm running out of time, so I just want to encourage you all to go back and review the PowerPoint. As I'm talking fast and trying to fit this all in 15 minutes, I might misspeak. If I misspoke at all, I apologize, but you can always depend on the information on the PowerPoint. It won't lead you astray. Email me with questions. Bye, everybody.